is Samuel Maher.
Maher.
On real-time convolutional neural networks for human detection and post-estimation.
Hi, I'm going to actually take this out for the presentation. Hi, so my name's Samuel Maher. I'm a rising sophomore in the College of Engineering, planning on studying computer science. And my project is using convolutional neural networks to detect humans and human posture. Oh, all right, wrong one. So why is this project important? So autonomous cars right now in their prime are really good at detecting objects that are static, so not moving. And one thing that robots have a really hard time doing is predicting the future and what's gonna happen. They're really good at knowing what's happening in the present. So what neural networks allow us to do is to analyze certain things such as skeletal features, as we'll talk about, and shape and sizes of people. And using those data points, we can better understand how objects are moving, what they're doing, and what their future intent is. So as you can see here, there's a guy who runs in front of a Tesla to see if it'll stop, which is a really bad idea that I don't recommend you do. But what my project is aiming to do in the future goal is to be able to analyze this person and say their intent is they're going to walk in front of that road. And we need to stop prior to when the person's in the road. So we're basically taking these data points and we're training a network to know future outcomes. So one of the neural networks that I use is called OpenPose. And OpenPose is a skeletal neural network. And what I mean by that is you have an image that you input, let's say. You have pre-trained data that basically gives you a confidence interval of different joints and limbs. And then using those confident values, we connect the limbs together, and then you get a skeletal array of, as you see here. And here is a video that is a pre-trained video, and this is what the car and the network would be seeing to analyze people's movements. The next one that I use is called MaskRCNN, which takes a new approach on a bounding box method, which is what a lot of people think of camera vision now. So as you can see, a lot of people think of this when they think of computer vision. You see an object, you classify the object, you have a value of how confident you are is that that's what the object is, and then you put a box around it. The problem with this is it's not very precise in giving you exact size, shape, and a lot of detail. So what MaskRCNN does is it takes this same method of bounding box, and it gets smaller and smaller and smaller until it actually wraps around the object, and it grayscales everything it doesn't detect. And as you can see, the girl's shirt is blinking, and the guy, all the objects it does detect, it puts it into the true value of what it looked like in the video. So what I've accomplished this summer is these two neural networks have only been able to be trained at the same time on pre-trained data. So if you input an image or video that you already had, you'd be able to get these different readings off of them. But what I aimed to do and what I accomplished was on a live feed, I was able to have both recognize these different details in real time. So here's the original video, and here's MaskRCNN running, detecting as we just looked at, and then here's the OpenPose. And then this is what we previously looked at when we were detecting these features. And what I did over the summer was I was able to take the two and put them together in one live feed that's running off of just this camera and my desktop. So as you can see, it's detecting every single one of you, person, 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 gives us your skeleton, and it gives us a confidence interval of if the computer thinks that you are like who you are. So you guys all have like 0.99 saying that you guys are people. And that's what I think you guys are. So future goals for this project that I kind of touched on were, what are we going to do with this data? So what the summer really accomplished was getting this real-time neural network up and running. And now the kind of project is leading to what do we do with it. And like I said, I really want to work on future intent so cars will know where people are going based off of this data. And I think that's really important because a lot of cars like that you've seen that are autonomous that crash now are due to super fast case scenarios where the car doesn't detect a lot of things. But if it had these branches of future moments, then we would be able to ultimately save lives in the end. And yeah, that's my project. And if anyone has any questions, I can answer them. My presentation is so short.
I'm trying to make it easier to see the slides.
Oh. So it's actually a random color generator. So there's a function literally called random_color, and then it just decides on